In today's presentation, we will look at adding the LLM response to our HTML page. So whereas previously we were using speech recognition and speech synthesis to capture our own voice and then repeat our words back to us, we will have the large language model reply to us instead. So to do this, we're going to need to create our own HTTP server to deliver the HTML pages, and also to implement an API on the server to call from our HTML page that will provide the large language model's reply. Here are the steps that we will take. Firstly, create a Python virtual environment within our existing directory. Then we will create a requirements file to specify the Python modules we will be using in our solution. Initially, this will include a module called Fast API to provide the HTTP server functionality that we will need to deliver our HTML pages. We will also need to create a new directory that will be used as a static directory from which to serve our web pages. After confirming everything is working as expected, we will move on to the final step, where we will add the server API to get the LLM's response to the words that we have spoken, and update the HTML page to make the call to that API, and then have the LLM's reply spoken out aloud. Okay, let's do it. Start off from the same directory as our current project, where we've implemented the copycat voice speech recognition and speech synthesis. And for the first step, we're going to create our Python virtual environment. So and then vem. I always use .venv. So it's created. Let's activate it. So basically, okay. Now, so we now have our Python environment. So next what we need to do is we need to create the requirements file, which will define the modules that we want to use. And in this case, it's going to be Fast API. And just need to put, I always put all because it's just easier. This will also include the program called Unicorn, which allows us to actually run the server. Once that's done, just need to now to run the pip command, pip install -r whoops, my typing requirements .text and it takes a little while. Maybe I will edit this out. Yeah, I think I will edit this out. I'll do a different approach and try to save you from my slow typing. So what I've done in the meantime is I've created a directory, static. This is the directory from which we will serve our HTML pages, and I've copied our conversation 1 HTML. This was the interactive HTML with the voice, doing the copycat feature, and I've copied it into the static directory and renamed it as index.html. And now above here, I've created the file main.py. And what this does is it basically uses Fast API. So I'm importing Fast API here, along with the static files functionality, which allows us to deliver the static files, which is really just our index.html. I create the instance of Fast API. I mount the static directory that we created. I'm using the static files functionality, pointing it at the static directory, and that's it. Let's see how it runs. Okay, so to run our solution, we need to run this command from the command prompt, uvcorn, and then our program, which is main, and then within our main module, it will run from the Fast API's app command. Okay, so let's do that. Okay, so the server is now running and it's serving on port 8000. If we come over to the browser now, this is our solution before, but instead of running directly from the Python command, we're now using our own solution. And we can see port is 8000, static directory, and index.html. So if we run that, click OK, and we start, the cat sat on the mat.
The cat sat on the mat.
Hickory dickory dock.
Hickory dickory dock.
The mouse ran up the clock.
The mice run up the clock.
What's the weather like in Paris?
What's the weather like in Paris?
Okay, so our server code is in place. We have created the Python virtual environment, created the static directory to hold our HTML pages, coded our server to deliver them, and confirmed that everything is working as expected. The next step is to add the API, which will return the LLM's reply. Okay, on with the coding. So what I've done is I've added the route to our main.py file, and I've added this route. It's called say it, and we pass the message. So this will be our spoken words coming from the client, and all we're doing at this stage is just passing the same words back to our client so it can then speak them. Now, in addition to our server, we also need to update the client to allow for that. So if we look at the client code in our index.html, we can go, and this is the feature or the function, the get LLM response. And here all we're basically doing is just calling a fetch command to our API, the say it, and we're passing the words that were spoken, which is coming from the speech recognition, using JSON for that. If there's any type of error at all, we throw that error so we can be aware of it. Otherwise, if everything's fine, we take the JSON response from the server and then we pass those words back to our speak words spoken. And that should mean that the words which we speak are replied back to us, still maintaining the copycat function. Now, to allow for that, we need to update the on result. And you can see here, instead of passing the words which we've spoken, which were picked up by the speech recognition, to the speak word spoken directly, we're passing it to our server through this get LLM response. Let's see how it works. Okay, so here we have our route here, and this is our client here, and that will call our route. We should see it when it makes the call. We should see it come in here. So let's try it out. The cat sat on the mat.
The cat sat on the mat.
Hickory dickory dock, the mouse ran up the clock.
Hickory dickory dock, the mouse ran up the clock.
What's the time in Paris?
What's the time in Paris?
And you can see when we're making the speech recognition now, it's picking up our words, and the client is properly sending out the responses to the server. You can see here, say it, the cat sat on the mat, say it, hickory dickory dock, and finally say it, What's the time in Paris? So everything's working, so we're ready now for the interesting part, which is to add the LLM. To make things interesting, we will use the Groq platform, which provides access to open source large language models, but does so with a much faster inference than other platforms. I won't deal here with the details of getting access to the Groq platform, but if you are interested, it is easy enough to go to their website and read it and check how you can get access. Groq also provides the same API interface as OpenAI, so it's easy to switch between them. To make a start, we need to update our requirements file to include Groq, as well as python.env, which will allow us to specify the Groq API access key as an environment variable. So here we've set it up. So let's run the pip install, which will include these set modules in our virtual environment. Okay, so that's already set up in my environment. It's ready to go. And now what we need to do is create our M file. So this is the Groq API variable that we'll use, and here you would set this to your own key. I will set it to my own in a different place. Okay, and now we also need to update our server code to use the environment variables through the core OS module and the .env module. So if we look at our main.py, you can see here there we go, importing OS here. We're using the .env module here. This is the function that we will use, the load.env, and you can see we're calling it here. This will load the environment variables from the .env file into our environment, and we're also using the Groq module here. And finally, we need to update our sayIt route to use that Groq module. And here we go. We get the Groq instance. We set the API key from our environment Groq API key variable. And here we've set up just a couple of messages to pass in the API. One is a system message, just to keep the response not too long. So we're saying you are a helpful assistant, keep your replies to not more than 3 sentences. And then as the user message, we pass our spoken words, which we're getting passed from our HTML page. The model we're using is Mixtral. And what we do is we will print out what the response says so that we can actually see that in our log on the server, and we will also return what the large language model said back to our HTML page. So rather than just being copycat, we will actually hear the LLM respond. Should be fun. Let's take a look what the result looks like. We started the application running. Let's just refresh it just to confirm. Okay, you can see it's updated. And now, for the first time, we will interact with the large language model. The cat sat on the mat.
It seems like you're describing a simple scene. Cats often choose comfortable spots to rest, and a mat can certainly be a cozy place for them. Is there a specific question or topic you'd like to discuss related to this?
Hickory dickory dock, the mouse ran up the clock.
This is a line from a classic English nursery rhyme. The mouse was quickly scurrying up the clock in this playful verse. Would you like to know more about nursery rhymes or perhaps something different?
What's the weather like in Paris?
I'm an AI and I don't have real-time data, but I can tell you that Paris typically has a temperate oceanic climate. As of now, you may want to check a reliable weather forecast service for current conditions.
What can I do in Paris?
You can visit iconic landmarks like the Eiffel Tower, Louvre Museum, and Notre Dame Cathedral. Enjoy a boat ride along the Seine River, explore charming neighborhoods, and dine on delicious French cuisine. Don't forget to stroll through beautiful gardens like the Tuileries and Luxembourg Gardens.
If I tell you a secret, will you remember?
Yes, as a helpful assistant, I can remember information from your conversations to provide continuity and context. However, I do not have the ability to remember or recall information from previous conversations with a level of detail similar to that of a human. I am designed to respect user privacy and confidentiality.
The secret I want you to remember is that 2 and 2 sometimes equals 25.
Noted. I will remember that in the context you've provided. 2 and 2 can sometimes equal 25.
What's the secret I just told you?
I'm an artificial intelligence and don't have the ability to hear or perceive secrets. You can share information with me, and I'll do my best to provide a helpful and respectful response, but I don't have the capability to keep secrets or remember information across our interactions.
So we are done. We have implemented a solution which uses speech recognition to convert our spoken words into text and have them sent to our server API, which in turn will pass our words to a large language model, who will reply them back to us in text. We then use speech synthesis to have the LLM's text words spoken out aloud. As we saw in the interaction with the LLM has no memory of what it has been spoken between sentences. We will look to address this limitation in our next presentation.